Okay, so this is chapter 10, Special Probability Distribution. But today we are going to learn 10.2, Poisson Distribution. Okay, so Poisson Distribution, we are going to denote them by X is a Poisson distribution with a lambda over here. So lambda represent the average. So this is the average in an interval of time or space. So lambda is the average in an interval of time or space. So we need to be very careful when we are dealing with Poisson. We need to see what is the interval that we are working with. So this is the formula for Poisson distribution. So since Poisson is a discrete random variable, we will have some value for the equal sign. So probability of x equal to x is simply e to the power of negative lambda, lambda to the power of x over x factorial. So basically we are going to use this formula only for the equal sign. Otherwise, normally we are going to use the table. So something that is more special about the Poisson is about the expectation, the mean, and the variance. So basically the mean and the variance, both of them are actually lambda. Okay, so let us go to the first example. So x is a discrete random variable with this is the average. So this is our lambda over here, 2.5. And then we were told to find probability for x greater than or equal to 2, x in between 3 and 4 inclusive, and then the mean as well as the standard deviation. Okay, so let me calculate A first. The probability for x greater than or equal to 2. So this one you can actually use your table straight away, or since I don't have my table, let me use the calculation then. So x greater than or equal to 2, this is simply 1 minus probability of x less than 2. Okay, so this is easier for me to calculate. That is why I choose x less than 2. So x less than 2 simply mean probability of x equal to 0 plus with probability of x equal to 1. And then we're going to use the formula for them. So probability of x equal to x. So this is e negative lambda, lambda to the power of x over x factorial. So basically we are going to use this formula. So this is 1 minus, and then we have e to the power of negative lambda, 2.5, lambda 2.5 to the power of x, 0 over 0 factorial. Do make sure to write down 0 factorial, otherwise this is undefined. Plus with e to the power of negative 2.5, 2.5 to the power of 1 over 1 factorial. And then once you use your calculator, this is simply 1 minus 0.0821 minus 0.2052, hence this is simply 0.7127. Okay, so that is A. So now let us answer B now. Okay, so B, probability for x greater than or equal to 3, but it should be less than or equal to 4. So what do we mean by this is that x should be equal to 3. So probability of x equal to 3 plus with probability of x equal to 4. So now substitute into the formula. So this is e to the power of negative 2.5, 2.5 to the power of 3 over 3 factorial plus e to the power of negative 2.5, 2.5 to the power of 4 over 4 factorial. And then once you use your calculator, this is 0.2138 plus 0.1336, hence this is equal to 0.3474. So this is the answer for B. And then E, we have to calculate the expectation. So the expectation is actually equal to our lambda. So this is also equal to 2.5. So that is for C. So for D, we have to be very careful. What we know so far is that our variance should be equal to lambda, and this one should be equal to 2.5. So the standard deviation is actually the square root of our variance. Therefore, standard deviation is simply equal to the square root of 2.5, and this answer should be 1.5811. So that is our standard deviation. So be very careful, variance, standard deviation. Okay, so let us go to the next example. So the number of accidents occur in a factory each week follow a Poisson distribution with variance 2.8. So we have X, so let X represent the number of accidents so this one each week, that means in a week. Okay, so X is a Poisson distribution, so the average is 2.8. Okay, so that is what we get from the first sentence. Find the probability that no accident occur in a particular week. So we are only interested in a week, so I can simply use the X. So this is probability of X equal to 0. So this is e to the power of negative 2.8. 2.8 to the power of 0 divided by 0 factorial, and then if you use your calculator, this is 0.0608. Okay, so now let us go to B. B probability that less than 3 accidents occur in a particular week. So we are looking at probability for X less than 3. Okay, so what we can do is that we can actually add probability of X equal to 0 plus with probability of X equal to 1 plus with probability of X equal to 2. So this is simply e to the power of negative lambda, lambda to the power of X over X factorial plus e negative 2.8, 2.8 to the power of 1 over 1 factorial, e to the power of negative 2.8, 2.8 to the power of 2 over 2 factorial. Okay, so this is 0.0608 plus, so the second one, if you use your calculator, this is 0.1703 plus, so this one again, if we use our calculator, this is 0.2384. So add everything, and then this one will give us 0.4695. So that is for B. Okay, so C, exactly 6 accidents occur in 2 weeks. As you can see over here, X represent the number of accidents in a week. But now we change it into 2 weeks, so I need to use another variable for this. So let me use Y then. So let Y represent the number of accidents in 2 weeks. Okay, so Y is a Poisson distribution. Okay, so if we have 2.8 in a week, in 2 weeks we should times them with 2. Therefore, this one should be 5.6. And then we are looking at exactly 6. So that means we want to calculate probability of Y equal to 6. So this is e to the power of negative 5.6. 5.6 to the power of 6 divided by 6 factorial, and this answer, let me see if I can squeeze over here. So this answer is equal to 0.1584. So that is the answer for the second part. Okay, so see you in the third part. Thank you.